In this video, we will create a curved 5-axis toolpath with tool axis control oriented to a point. The curved 5-axis toolpath can create a 3-axis, 4-axis, or 5-axis toolpath along a 3D curve or along one or all edges of a surface. The tool axis can be oriented parallel to existing lines, normal to a surface, normal to a plane, oriented from a point, or to a point. Change the graphics view to top and fit this to screen. Click on Toolpaths and select Multi-Axis. Select OK to accept the default NC name. Once the dialog box appears, ensure that you select Curve as your toolpath type. Then select the tool page. Select a 1/16 flat end mill from the tool library. Then enter in the comment. Select Cut Pattern. Beside Curve Type, click on the Select button here to select points. Change your chaining method to Window, and Color Mask on color number 9. Create a window around the part. Choose your approximate start point somewhere over here. Then select the OK button to exit the chaining dialog box. In the Curve Type area, leave this set to 3D curves. The cut tolerance determines the accuracy of the multi-axis toolpath. Maximum step sets the maximum space allowed between tool vectors. Additional vectors may be desirable in areas where the tool travels in a straight line for a large distance. With projection set to normal to plane, this projects the curves to the tool axis surface, using the current construction plane as the projection direction. Projection set normal to surface projects the curves normal to the tool axis control surfaces. Select Tool Axis Control. This settings determine the tool's orientation in relation to the geometry being cut. Change Tool Axis Control to 2-point, then click on the Select button. Change the view to isometric and unshade the part. Choose this point here. With the tool axis control set to point, this limits the tool axis to terminate at a selected point. Output format set to 5-axis allows the tool's axis rotation in any plane. Lead lag angle tilts the tool forward or backwards in the direction of the toolpath. Side tilt angle tilts the tool left or right while traveling in the direction of the toolpath. And angle increment is an angular measurement between adjacent tool vectors. An additional vector will be added to the toolpath when the angle between calculated vectors is greater than the angle increment value. Select Collision Control. Change the vector depth to -0.35. The collision control settings determine tip compensation, establish check and compensation surface behavior, the depth at which the tool cuts along the curve, and to set gouge process settings. Infinite Look Ahead checks every tool position against every other tool position in the operation to check for gouges. Select Linking. Change your clearance value to 5. Enable Retract with a value of 4. Change your feed plane to 1/4 of an inch. Select the OK button to generate this toolpath. Once the toolpath is finished generating, backplot and verify this toolpath. Once the Verify is completed, select the Verify tab. Select Keep Chips and choose this part of the solid here. Then you will see the finished product. Close the Mastercam simulator once complete. Then, toggle the toolpath display.